ORC stands for Organic Rankine Cycle. An organic Rankine cycle is a closed-loop thermodynamics cycle that converts low to medium temperature heat sources into electricity. ORC uses organic fluids with lower boiling points that ORC technology can win where steam turbine cannot operate. That means that in low to medium enthalpy heat sources, geothermal heat sources, ORC can generate electricity where the steam turbine can't. The question is getting more interesting when we go actually to the small size units. Let's say when I have 1 megawatt or 5 megawatt. Would it be better to put 2 small units or even 4 or 5 small units, which really allows me to modulate or to play with the power output?
Welcome to Geothermal Unleashed, where we will explore the cutting edge of geothermal energy. I'm Elizabeth Cambre from the Valorec New Energies team. I am here to help educate and document geothermal's rise in the global energy transition. Today, I am delighted to welcome my guest, Yehonatan Fein. He is the ORC power plant expert and project engineer at Vulcan Energy. Today, we're going to talk about everything ORC, Organic Rankine Cycle. Yehonatan, welcome. And I would like to kick things off by asking you to introduce yourself and how you came to be in the geothermal industry.
All right. Well, thank you, Elizabeth, for the introduction. So the story with geothermal energy and with ORC started actually about 11 years ago, short after I graduated from university. And I really wanted to find myself working in the field of renewable energy. Yeah, I didn't know nothing back then about geothermal, but I was looking for a job. And of course, as a fresh new engineer in the market, I really wanted to do something significant and to have my impact on this world. So I really wanted to do renewables, and I was started looking for a job in solar photovoltaic panels, and of course some wind turbines. But then it came up to my knowledge that there is a big company which is called Ormat, one of the leading companies, or maybe the biggest company in the world for ORC technology. And we will talk about ORC in a minute. And came up to my knowledge that they exist, and I applied immediately for a job over there, and I was invited for an interview, and I passed, and the second interview as well, and I started working in Ormat. That was in 2015. Ormat is let's say, the biggest player in the field of ORC technology, and mostly in geothermal applications. And wow, that was a real journey for the last 10 years. And I grew up in this company, and I gained a lot of knowledge and experience and hands-on and theoretical experience. I took place in different roles in the company. And then last year, I decided that, well, after 10 years in the company, it's time to move on. And I joined Vulcan Energy, which is a company based in Germany. It's an Australian German company. You can find a lot of information about them online. And they also do geothermal energy. And I am the project engineer for their ORC in their facility. So this is my journey in the geothermal world, yeah, and the ORC world.
Exciting. So I have yet to talk about organic Rankine cycles, or ORCs, on my podcast. So why don't we start with just a basics? Can you explain to our listeners what ORCs are? How do they differ from steam turbines, and why they are so important for the geothermal industry?
Sure. So as you said, ORC stands for Organic Rankine Cycle. So basically, an organic Rankine cycle is a closed loop thermodynamics cycle that converts, let's say, low to medium temperature heat sources into electricity. It differs from steam turbine in the fact that ORC uses organic fluids with lower boiling points, which is enabling us or enables us to use the heat sources that are usually too, let's say, too cold for conventional steam cycles. So the ORC opens another world of heat sources that were never used before just because they are not energetic enough. And we are able to harness this energy to generate electricity. And of course, geothermal energy is one of those heat sources. We can now use low energy heat sources, geothermal heat sources, to generate electricity.
Okay, so you said it's a closed loop. Can you
Yeah, it's a
explain what
closed
you
loop.
mean by
Mhm.
how it's a closed loop, and is a steam turbine a closed loop?
So let's focus on the ORC for now, and we will say that the ORC is a closed loop, which contains, I put it the most simple way, four main components. We have the vaporizer or the heat exchangers, then we have the turbine, we have the condenser, and then the pump. So basically, we introduce the geothermal heat into the heat exchanger, to the vaporizer, where it will heat up and boil a fluid which is flowing in a closed cycle. This fluid boils in lower temperature than water. It will boil, change its phase into vapor, and then these high pressure, high temperature, high energy vapors will drive a turbine. This turbine is connected to a generator, which will convert this rotational mechanical energy into electrical energy. And those vapors that now did their job in the turbine will flow to the condenser, which can be an air-cooled condenser or a water-cooled condenser, get condensed back to liquid. From the condenser, they will flow back to the pump, and from the pump back to the heat exchanger to absorb more heat from the geothermal fluid, and then turbine again, condenser, pump. So the cycle is an endless cycle as long as we provide the ORC with heat source. The ORC can keep generating power or electricity. So inside this closed loop, we have organic fluid, usually some kind of hydrocarbon, such as pentan or butane. Sometimes we can use different types of refrigerants, and so on.
Okay, so let's talk a little bit about thermal conversion efficiency. So how efficient are ORCs compared to steam turbines, and what are the expected thermal conversion efficiencies of the ORC systems in general?
So, um, of course, as every product or every power plant, the bigger we get with the unit size or the unit power output, and as we have more heat source available, that means more flow and higher temperature of geothermal fluid, the efficiency of the unit will be better. So for the small units, I don't want to give like an exact number, but for the small size, container size unit, we're talking about 10, 12, 13% of efficiency. That means from 100 megawatt or 100 megawatt of thermal heat, we can generate around 10 or 12 megawatts of electricity. And on the bigger units, we can get up to 16, 17, 18, and even slightly better efficiency. So it goes around those numbers, 10 to 20% of efficiency.
Okay, I've got a question. Let's say you've got a geothermal field that could use steam turbines. Could
Mhm.
you use organic Rankine cycles in place of steam turbines, and would they have more efficiency because it's higher temperatures?
That's a good question. Yeah. So if you ask me this question, let's say 5 or 7 years ago, I would definitely say that steam turbines are winning in the high temperature, high energy, or high enthalpy geothermal fields. But today, most of let's say, the big names or the big players in the field of ORC technology are getting better and better, and they are able to generate more efficient and larger units, which starting to bite more in the, let's say, in the field of steam turbines. So if we talk about units or about up to 20 megawatts with a low enthalpy heat source or medium enthalpy heat source, ORC wins, and it can compete with steam turbine, I would say, up to 50 megawatts. Yeah, I'm not really aware of the latest numbers and the latest technologies, but let's say up to 50 megawatts, there is a big, good chance for the ORC. If we are talking about higher, bigger projects with high enthalpy steam, then the steam turbine will still hold its place. Yeah.
Okay. But there is a benefit, right, of using an organic Rankine cycle versus a steam turbine in general. Maybe maintenance, the fluid's not exposed to the turbine blades.
So, of course, that ORC technology can win where steam turbine cannot operate. That means that in low to medium enthalpy heat sources, geothermal heat sources, the ORC can generate electricity where the steam turbine can't. The second thing, which is really important, is the fact that in steam turbine, the expansion of steam inside the turbine happens from superheated steam into usually into a two-phase water steam. That means that we will usually see after a few years damage to the turbine blades, which will require an overhaul of the turbine, which takes long time, which is expensive, and it's a long downtime of the equipment. On the other hand, ORC technology usually uses hydrocarbon as the motive fluid, and the expansion inside the turbine happens outside of the two-phase area. That means the expansion is a dry expansion, means zero damage to the turbine wheels. And I saw some turbines that were opened for inspection after 10 and after 15 years of operation, and the blades look brand new, really. Nothing needed to be performed on the blades themselves. So this is a big advantage for the ORC technology.
Okay, let's talk a little bit about temperatures, and let's look specifically at how the geothermal brine temperatures affect ORC efficiency and equipment selection.
Mm-hmm. So, of course, with geothermal energy, every geothermal reservoir is changed, and the properties of the geothermal fluid are different from one geothermal well to the other one, and of course, between different areas and between different countries around the world. And so does the temperature range, and so does the flow. Some, so of course, we will have a different design to the ORC. In some cases, we will need to use different materials, stainless steel, super duplex, more complex and more expensive metals in our equipment, such as heat exchangers. In some places, we can use, let's say, cheaper and lower quality materials because the brine is not that aggressive. Yeah.
Okay.
One more thing that I would like to add is that, of course, having different temperatures on different geothermal reservoirs will allow us to use different size or to build different size of ORC. So if the temperature is, let's say, between 95, 100 degrees Celsius, we're talking about the lower range of temperatures, we will have less efficient usually and less and smaller ORC. And of course, if we go to the higher numbers, we talk about 160 up to 180 degrees Celsius with high flow values, we will have more efficient ORC and we can generate more power out of it.
Okay. What are the typical sizes and footprints of ORCs? And do we see most of the geothermal developers purchasing smaller modules, or do they go with larger ORC units?
So that's a question that I was let's say, working with in the last years.
Okay.
So we start with the smallest units. I was working in a unit on an ORC unit in Austria, which is generating around 200 kilowatts of electricity from a heat source, which, if I remember correctly, was around 100 degrees Celsius. So really on the lower range of almost the lower limit of ORC technology. Yeah. And then on the other hand, I was working on 25, 30, or even 40 megawatts units in the United States. So we talk about a big range here. And if you're mentioning the footprint of such a unit, so I go back to the smaller unit in Austria, 200 kilowatts. I would say that the size of the unit is basically 2.5 up to three normal size shipping containers. Yeah. So we're talking about a footprint of 10 by 10 meters. Yeah, very, very small area. And if we go to the larger units of 25, 30, 35 megawatts, then we are talking about an area which is still considerably small compared to, let's say, photovoltaic solar panels. So for 30 megawatts power plant, I would say an area of around 100 meters, 150 meters by 50 or 70 meters. So this is around the numbers that we are talking about. Yeah.
Okay, but let's say you've got a 100 megawatt plant that you need to build. Would you put in smaller 10 megawatt or would you go with a 50 megawatt unit? I mean, I would assume you'd want some redundancy. And how do you
Mhm.
design? How do you select
So
the sizes?
so if I have, let's say, if I have a heat source which allows me to develop a 100 megawatt ORC technology, I will usually divide it into smaller units, yeah, just to have the redundancy and to be able to to be able to perform maintenance on one unit while the other unit keeps running. So I always keep the revenue going in. I can maintain one unit or even half a unit and then keep working with the other parts. The question is getting more interesting when we go actually to the small size units. Let's say when I have a 1 megawatt or 5 megawatt, would it be better to put two small units or even 4 or 5 small units, which really allows me to modulate or to play with the power output? It's also a question of the stability of my geothermal field. Yeah, sometimes I won't have the entire flow. In some cases, I would like to use the geothermal flow for other aspects, let's say like district heating to warm up houses. So in some cases, I want to divert some of the flow to a different aspect or to a different plant. In this case, if I have few modular small units, I can just shut down 2 or 3 out of the 5 and keep running the other. So it's a more question of the size of which and it plays more role in the small scale units.
That's interesting. But I mean, does it get more expensive if, let's say, you had 5 megawatts and you wanted to have multiple smaller units? Is that way more expensive than buying one 5 megawatt unit?
Yes, I assume. But again, there is a question here because if I buy like an off-shelf product of an ORC, just a cube ORC, then uh, I can just buy 5 of the same unit. But usually it would be cheaper just to buy one ORC because I save a lot of equipment. I don't need 5 different turbines. I only have one. I have less heat exchangers. I have less pumps and so on.
Yeah. But you may not then, what I'm understanding is you don't have the redundancy, and then you may not be running most efficiently. Is
So
it?
there is a big benefit for the ORC technology, which allows you even, let's assume that we have 5 megawatt um, power output unit. I can still play somehow with the power output. So if I have less heat source available, the ORC technology can, let's say, fit into different amounts of flow. So if my flow, let's say, is 50 liters per second, the ORC will know how to handle also 40 and 30 and even 20 liters per second and still generate something. Of course, it
Okay.
will become less efficient, but the best, if I know that I need to change and I have fluctuations in my heat source, I think that the best thing will be to put small
Yeah.
units. Yeah. But this is
Yeah.
only if I know for sure that I will have fluctuations and difficulties running my geothermal field.
Yeah. And is that something you can plan for in advance or is
That's the big question. Yeah, if you're still developing your geothermal field, maybe it's a good idea just to put modular units and then just add one after another. But usually the ORC will be selected after we know what we have in the geothermal reservoirs. So we already have more or less the numbers.
Wait, can you really select the type of ORC after you've started drilling? And because the lead times, and that was one of my questions that I want to ask. The next question is, what are the lead times on ORCs? And are the manufacturers going to be able to meet the demands of the power plants that are going to expect it to come online in the future?
Yeah, that's a really good question. And yes, of course. So it's always a question you're going to invest a lot of money in drilling and on production and injection wells. And well, you can do some. I'm not that's not my field of expert, the geothermal side, but of course you do some estimations on what you're gonna have, and then you drill, and then you do some tests for each well, so you get better results and better knowledge. And meanwhile, you already want to be in the process of ordering a new ORC, yeah, because as you said, the lead time and the supply time for ORC gets up to 2.5 years for the big units. Yeah, maybe container sized units, of course, are more valuable and require less supply time. But the supply time for ORC was really affected during COVID. Yeah, like everything else in the world, of course. And we could see that the waiting time for generators, for pumps, were getting longer and longer and longer, which really affect the supply time for an entire ORC. But from the way I look at it on the recent years, everything is getting better and better, and we start to go. And I think that these days we are closer or back at the same numbers we had pre-COVID.
I
Yeah.
see. Okay, so we've talked a little bit about key criteria that geothermal developers would use when they're selecting the ORC manufacturers. But maybe you can hit on this again and just summarize when you're selecting ORCs, what do you have to think about? What goes into this?
So of course we start with the heat source. Yeah, the heat source, how much we have, flow, temperature, the properties of the geothermal fluid. Of course, each country and each place around the world has different regulations and different standards that we need to meet. Yeah, I know that all of the big players in the world of ORC, they know they've been everywhere. They've been developing ORCs all over the world, and they know how to build an ORC to meet the specific regulations for each country. But of course, you need to know the first question will be how much thermal heat do you have? And if it's economical to put an ORC. So in some countries, the 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 payment for electricity will be significantly higher, let's say in geothermal ORC than in photovoltaic solar panels. In some countries, the numbers can really jump up to crazy figures that everyone would like to put an ORC, but in some cases it also meets different and more difficult local regulations. So it's always like a game of balance. So first, I would like to know how much energy, how much thermal energy I have, what are the properties of my geothermal reservoir and the geothermal fluid, of course, temperatures and flow. I will need to know the regulations in my country regarding the ORC, installation of a geothermal ORC, of course, connection to the grid, putting equipment in, using an hydrocarbon as the motive fluid, and so on. So, but the basics, of course, is how much heat I have, how much thermal energy I have, and then I can calculate if the ORC is economical or not.
Fair. Okay. Is the industry exploring advanced working fluids? So you mentioned an example of working fluid would be like pentane. Or are there other novel turbine designs that are being investigated to improve the ORC performance?
Mhm. Yeah, so of course, the the selection of motive fluid inside the ORCs also relates somehow to the properties of the heat source. So for higher temperature heat source, I will use different type of motive fluid. For example, starting with the low temperatures, usually I will use some kind of butane. And if my heat source increases towards the higher values, the higher temperatures, I will move to pentane, isopentane, normal pentane, and cyclopentane on the higher temperature range. In some countries, there are some strict regulations about some types of hydrocarbons. For example, we can replace the pentane or hydrocarbons with refrigerant. For example, R1234, or I don't remember other models, but it can also be taken into consideration when designing an ORC. Of course, it depends on the regulations, the price, the market price for the motive fluid, and so on.
Could you go to lower temperatures, get fluids that have lower boiling points to be able
Mhm.
to harness cooler temperatures? Is that something that's being worked on?
Yeah, that's more or less correct. So if you go with the lower temperature heat source, I will use the motive fluid which fits those conditions that I have. Of course, that will affect somehow the efficiency of the ORC, but I want to, let's say, squeeze as much as I can from what I have.
Okay. All right, let's turn to talk about combining direct use geothermal with the operation of ORC for power generation. Can we combine direct use and power gen?
Yes, of course, it's very common to combine the different uses of geothermal energy together with the ORC. So the ORC will usually give me one aspect, which is the electricity production, but it doesn't end there. And this is what's so beautiful about the geothermal energy. So I can harness some of the energy to generate power of the ORC. I can also control the amount of power that I want to generate. So if I don't need the entire power output at the moment, I can, let's say, switch some of the energy to different uses. For example, a very common use is district heating, which means that I can use the geothermal energy or the geothermal brine that leaves the ORC to warm up houses, which is a very common use, especially on the recent years when the gas prices increased dramatically. Um, and for more fun uses of geothermal energy, of course, coming out of the ORC, I was visiting one ORC plant that was installed inside a thermal spa hotel. So the geothermal fluid goes into the ORC, generates some electricity, and then the cooler brine leaves the ORC and goes into the thermal pools of the hotel, which was really nice. In one ORC in Japan, um, so the brine and steam goes into the ORC and then leaves the ORC and uses for the traditional Japanese baths. That means the onsen, which is very common in Japan. and also in the winter to melt down snow from the sidewalks. So there are a lot of uses, and we can combine those uses together with power generation in the ORC.
I think that's so fascinating. Well, my final question for you today is a general one. What do you see as the future of geothermal energy, and what are the biggest challenges that we have to overcome as an industry?
So what I see in the recent years is that first I see that the big players in the market is starting to introduce bigger and bigger units. So the ORC technology bites more and more of the steam turbines. Yeah, of course, when we are still talking about high enthalpy steam, the steam turbines still have its own area, which it's more difficult to interrupt. But the ORC technology is getting better and better and more efficient and more economical and more reliable. And we can see today ORC units that generates 40, 50, or even 60 megawatts, which is something that was unimaginable, let's say 10 years ago. And I'm talking about an ORC such as two turbines and one generator. Of course, we can connect multiple units like this and generate how much power that we want. Then, on the other hand, we talk about it's something that I start to see on the recent years that are more and more companies that generate or manufacture small scale units, starting from 50 kilowatts up to 100 and up to, let's say, 1 megawatt. So we're talking about two different aspects. A lot of companies that are creating small scale ORCs and the bigger players in the market that are getting larger and larger units over the years.
I love it. It's always a fast-moving industry. Well, I want to thank you for joining us on this episode of Geothermal Unleashed, Yehonatan. I really enjoyed learning and diving more into the ORC technology. I hope today's discussion has sparked new insights and deepened everyone's understanding of the geothermal industry's incredible potential. Until next time, let's keep pushing the boundaries of what's possible, and let's continue working together to unleash the full potential of geothermal. Thank you.
Thank you.